Welcome to The Explainer, where we break down big topics.
So could our entire universe actually exist on the other side of a black hole? I mean, wow. Today we're tackling some of the biggest, wildest questions about the cosmos, and we're going to use insights from astrophysicist Neil deGrasse Tyson to guide us. It's going to get weird. Okay, let's dive right in. But before we get too out there, we're going to start things off a little closer to home. Let's talk about our own solar system.
All right, so a viewer asked a really cool question about long-haul space travel, like a trip to Mars. Think about it. Instead of just floating around for 9 months, could you just make your own gravity?
And the answer is a big old yes. And how you do it is actually pretty elegant. You just fire your rockets, accelerating for the first half of the trip. Then, at the halfway point, you flip the whole ship around and fire the rockets again, this time to slow yourself down. You'd arrive at Mars with your feet planted firmly on the floor the entire time.
So why does that even work? Well, it all goes back to the genius of Albert Einstein and something he called the equivalence principle. He figured out that your body, if you're inside a closed box, like a spaceship, literally cannot tell the difference between the pull of gravity on Earth and the push of a rocket accelerating. To you, it feels exactly the same.
And this, right here, leads us to one of the biggest myths in sci-fi. You've seen it 1,000 times, right? The spaceship's engines are firing, everything's rattling, but inside, the crew is just floating around, totally weightless. Now, that's just wrong.
Here's the key thing to remember. You're only weightless when you are in free fall. The astronauts on the International Space Station, they're just constantly falling around the Earth. A spaceship drifting silently between planets, it's falling through the cosmos. But the very second you turn on those engines and start pushing, you are not weightless anymore. You've got weight.
Okay, moving on. Here's something you might have wondered about. We call planets like Jupiter and Saturn gas giants, but they have solid cores, right? And Earth has a solid core and a gassy atmosphere. So what's the deal? What really makes them a gas giant?
Well, the best way to wrap your head around it is with a little food analogy. Think of Earth's atmosphere. It's like the skin on an apple. Super important, for sure, but it's an incredibly thin layer compared to the whole thing. Now, a gas giant, that's more like a peach. Its atmosphere is the thick, juicy flesh that makes up almost the whole fruit, with just a tiny little pit in the center. See the difference? For them, the gas is the planet, pretty much.
Okay, so we've had a nice little tour of our cosmic neighborhood. Now, it's time to go deep. Let's venture out into the truly mind-bending stuff.
And believe me, it doesn't get much weirder or more mind-bending than this idea of a mysterious substance called strange matter.
So to get this, we have to shrink down way, way down to the subatomic level. The protons and neutrons that make up, everything. They're made of tiny particles called up and down quarks. But, and this is the cool part, physicists discovered there are other, heavier types or generations of these quarks. And one of them is called the strange quark.
And here's a great little piece of trivia for you. The physicist who came up with this, Murray Gell-Mann, needed a name. He actually snagged the word quark from a super obscure line in a James Joyce novel, Finnegan's Wake. Why? Because he originally thought there were only 3 of them. 3 quarks from muster mark.
Okay, so what is strange matter then? Well, it's this theoretical stuff where under the insane crushing pressures you'd find inside a collapsed star, these strange quarks could actually become the dominant particle. The whole thing could basically turn into a giant ball of strange quarks. If something like this, a strange star, actually exists, well, that's a whole new state of matter we never knew was possible.
And this kind of brings us full circle, back to that mind-blowing question from the start. Just look at this. On one hand, you have the edge of our observable universe, the absolute limit of what we can see. And on the other, you have a black hole's event horizon, the point of no return. Here's the kicker. Mathematically, they share the exact same properties. Is that just a wild cosmic coincidence, or could it be that our entire universe is what's on the other side of a black hole's event horizon?
Okay, let's pull the camera back, way back, and think about us, humanity. Where do we fit in all this? If there is anyone else out there, what do they see when they look our way? And, maybe more importantly, how could we hide if we wanted to?
For most of the 20th century, we were basically screaming into the void. All our old radio and TV broadcasts were just leaking out into space, creating this ever-expanding bubble of noise traveling at the speed of light. But then, a funny thing happened. Cable TV came along, then fiber optics. Our signals got contained. And from a galactic perspective, we actually got quieter.
So let's flip that. What if a really advanced civilization wanted to hide on purpose? How would they do it? Well, their best bet would be perfect encryption. See, a perfectly encrypted signal is so random, so chaotic, that it looks exactly like the natural background noise of the universe. You could be pointing your telescope right at them, listening to their signals, and you just think you are hearing empty space.
And the irony here is just great. While we're talking about how to hide, a generation of scientists before us did the absolute opposite. Back in the 70s, they put these plaques on the Pioneer spacecraft. It's basically a cosmic welcome mat, a "You Are Here" map that shows any aliens who find it exactly how to get to our solar system, using pulsars as a guide.
But maybe there's an accidental disguise built right in. See, that map clearly shows 9 planets, because, Pluto was still a planet back then. So maybe any aliens who find it will be zipping through the galaxy looking for a 9-planet system, and they'll just fly right by our little 8-planet system without a second glance. Whoops!
So this all brings up a good question. With these giant billion-dollar telescopes like the James Webb, is there even a point to be an amateur astronomer anymore? Can a regular person in their backyard still make a real discovery?
And the answer is absolutely. In fact, amateur astronomers are more important than ever. The big professional telescopes have their schedules booked years in advance. They can't be looking everywhere at once. So it's often the amateurs who spot the unexpected things. A new comet, a distant supernova. Plus, they help out with huge citizen science projects, helping pros sort through just mountains of data. Okay, last thing, and it's a big one. Let's talk about how science really works. What happens when some new discovery comes along that seems to, break everything we thought we knew?
You've probably seen this recently. The James Webb Space Telescope found some galaxies way back in the early universe that were, bigger and more developed than our models said they should be. And of course, the headlines went nuts. The Big Bang is wrong. Scientists baffled. But that's not really what's going on at all.
Here's the real story. The Big Bang theory itself, that's supported by a mountain of evidence from all different directions. It's solid. What the telescope found was a problem with our models of how the very first galaxies formed. And that's a huge difference. We're not throwing out the entire foundation of cosmology. We're just fixing and refining a tiny piece of it, which, by the way, is exactly what the telescope was built to do.
And that, right there, is the heart of science. It's not some dusty book of facts that never changes. It's a living, breathing story that's constantly unfolding. Every new discovery, every time we have to correct a model, it doesn't mean we failed. It means we've just learned enough to ask an even better, even more exciting question.